Now let's take a look at some of the commands that we have in Rhino. So in the previous videos we have seen that commands can be executed in Rhino both using shortcuts and using the command line. So we'll be taking a look at some of the basic and advanced commands that we can execute using both the command line and or the shortcut buttons. So let's try using the basic ones first. So you have the point command where you type in point, and you can see the first command that comes up. So you have a lot of options for points. Let's try using the first one, which says point. You can click on that. It is asking you for the location of the point object, and wherever you want your point you can place it like that. And now we have line, so you can just type in line in Rhino like this, and you have the first command which says line. You can click on that and it will ask you for the start of the line. So you can click for the start of the line, and then you can extend it like this for the end of the line, and you can click it. So you have a line and a point over here. So let's try using the next command, which is called polyline. So you have polyline over here. So you can just type in polyline. You can see the third command on the list. You just click on that and it will ask you for the start of the polyline. So you can go on creating random polylines like this, and it won't stop until and unless you are done. So this command is really useful for making floor plans, and once you're done you can just hit enter. So you have a point, you have line, and you have a polyline. Now let's look at surfaces. So let's try creating a planar surface. So for creating a planar surface you need to have a planar curve first. You can just go on and create a surface using shortcuts like this, which says surface from 3 or 4 corner points, or you can go over to surface and you can go to plane and you can use the corner to corner or all these commands to create a surface. But let's take a look at how we can convert a closed curve into a planar surface. So to create a closed curve we can just type in rectangle and hit enter, and let's create a rectangle like this. In order to convert this particular closed curve into a planar surface, we'll just type in planar surface. It spells like this. It spells PLANAR and SRF with a capital S. So that is the shortcut for surface. So you can just type in planar surface and you can just hit enter. Once you hit enter, you can see that this particular curve has been converted into a planar surface. You can turn on the shaded view from the drop down button over here. You can see that you have a planar surface. Planar surfaces can be created not only using orthogonal closed curves but also using random spline closed curves. So you can also create a planar surface using control point curves from this shortcut. So you can just select the shortcut from over here and you can create a closed curve like this. We can also turn this into a planar surface. Just type in planar surface like this and hit enter. You can see. So this particular command works both ways. Now let's take a look at the command known as extrude. For understanding the command extrude, we will extrude 3 kinds of geometries. We'll extrude a point and we'll see what happens. We'll extrude a line and we'll see what happens. And we'll also extrude a surface and see what happens. So if you select a point, you can extrude any geometry using these circles. You can just click and drag. But let's try using the command line for extrude this time. So you can just type in extrude. Once you type in extrude, you'll see you have a lot of different options for extrude. So over here you have extrude curve and you have extrude surface, but you do not have a command called extrude point. So for extruding this point, we'll be using the gumball tool. So you can select your point and you can select the direction that you want to extrude, the dot that you want to extrude in. You can click on it and you can drag like this. So if you extrude a point, it will be turned into a line. Now let's try extruding a line. You can select your curve and you can type extrude, and as you can see, the first option which says extrude CRV is short for curve. So you can click on that and it will ask you for the extrusion distance, and as you can see, you have a lot of options for extrusion distance over here. After extrusion distance, you have direction, you have both sides, you have solid, you you have delete input, you have to boundary, and you have set base point. So let's take a look at the option known as direction. You can click on direction and it will ask you for the base point of direction. Now what this actually is asking you for is the direction of extrusion. So this particular curve, I want to extrude it in the Z direction. So then I'll go over to my front and my right views for a better understanding of the direction I want to extrude my curve in. You can actually turn all the views to shaded mode so that you can actually see the surfaces and the curves that you are working with. So for the direction of extrusion, I will be extruding my curve from this particular point to the Z direction. So I'll click on the point, the base point, and now as you can see in the command line, it's asking for the second direction point, which I'll place somewhere over here. It signifies the Z axis. Once you are done with that, you can see in the perspective window, your curve is actually getting extruded in the Z direction. Now you can actually type in a particular distance over here in the command line. You can also check both sides to yes. If you check both sides to yes, then your curve will be extruded in both the sides, which is Z and minus Z, as you can see. Let's turn that to no and keep it as it is, and let's keep the extrusion distance to 5. Hit enter. Now our curve has been extruded 5 meters in the Z direction. Let's try the same command again and extrude it to a higher distance this time. Select the curve, you can press enter. Once you press enter, you can extrude it somewhere around this height. And now you have an extruded surface from a curve. Now let's try extruding a particular surface and see what happens. So let's try extruding these surfaces that we have just made using the planar surface command. So let's try extruding this. You can select this and type extrude. Now for extrude, you have different options. In the previous one, we had extruded a curve, for which the command was extrude CRV. This time we are trying to extrude a surface. So the command is extrude SRF. As you can see in this command list, you have extrude SRF over here. So you can click on that, and as you can see, it's the same as before. It's asking you for the extrusion distance. You can check the direction from over here. You can turn on both sides if you want to. You can also turn on solid to yes in case you want a capped surface. So let's see what happens if we keep solid to no. If you turn solid to no and if you give it a distance and extrude it and click it, you can see the top of the cuboid is missing. You can use Ctrl Z to go back, and if you select your surface again and type in extrude again and select extrude surface from over here, this time if you keep solid to yes, and if you give it a random distance like this and click, this time you can see the top is attached to the entire cuboid. So you have a solid cuboid. If you keep the solid to yes, the entire geometry will be one single unit. So you can also extrude organic planar surfaces like this. So you can click on your surface and you can type in extrude, select extrude surface from over here. You can extrude it up to a random distance like this. As you can see, since the solid was turned to yes, I have a capped solid like this. You can also extrude polyline. So let's try extruding the polyline that we just made, this particular polyline. Let's select the polyline and type in extrude. You have extrude curve as the first option. Select that and you can extrude this polyline up to a particular distance. And click when you're done. You can extrude a polyline in this particular fashion. Now let's take a look at moving, scaling and rotating any kind of geometry that we have on our viewports. We have already covered the moving, scaling and rotating parts using the gumball tool, but you can also perform the same actions using the command line. So let's take a look at it. If you select any geometry, for example, if I select this box, I can move it using the arrows like this, using the gumball arrows. I can scale it using the gumball squares that you have over here like this. I can also rotate it using the gumball arcs that you have like this. You can turn the ortho off on the bottom, and then you can rotate it in any plane that you want to. But these actions of moving, scaling and rotating can be performed using the command line also. So let's take a look at it. We can use this particular solid, move, scale and rotate. Select your object and you can type in move and hit enter. So it will ask you for the point to move from. So for example, if I want to move my object from this particular point to a random point on the viewport, so I click on the point that I want to move from, then it will ask me for the point to move to. If I want to move this particular solid on the edge of this particular rectangle, move it to that point and I'll click. Now I have moved my solid to the edge of a particular geometry. That's how you can move one object from one point to another. Now let's try scaling and rotating this particular object. You can hit Ctrl Z to go back to the original destination, and now you can select your object and you can type in scale. So you have a lot of options for scale. You have scale 1D, you have scale 2D, which is 1 dimension and 2 dimension. In 1D, it's essentially scaling it in one particular axis, either X or Y or Z. For 2D, you can scale your object in two axes at the same time. So you have a lot of scaling options like that. Let's try using the first one, which says scale. You can click on that and it asks for the base point. So the base point of scaling, you can select a base point like this, and now it is asking you for the scale factor or the reference point. Now either you can click on a reference point anywhere on the viewport and then drag to scale it, or you can give it a scale factor. Let's try using the first one. Let's try clicking on any point, random point like this, and let's try scaling it. So as you can see, if I move my mouse further along the line, I'm scaling it to be bigger, and if I move my mouse further below the line, I'm scaling it to be smaller. So you can scale it like this, which is not a very accurate way to scale, but you can also use the same scale command, and this time you can select a base point and you can scale it using a scale factor. So you can put like 2.5 and you can hit enter, and now your object will be scaled 2.5 times of its initial volume. So that is moving and scaling. Now let's take a look at rotation. You have a lot of options for rotation in Rhino. Let's try rotating this particular geometry. So you can type in rotate. You have rotate 3D, you have rotate camera. You have a lot of options for rotate. Let's try using the first one. You can hit enter, or you can just click. You can select your objects for rotation. You can select this object and you can press enter when you are done. Now it is asking you for the center of the rotation. Let's try rotating this particular object in a top view in our plan. So you can move into the top viewport and you can select the center of rotation. Let's try keeping the center over here, and now it's asking you for the reference point or the angle. Let's give it an angle like this. Let's turn on the ortho and give it a reference point like this. So the kind of rotation your object will go through depends on where you are giving your reference point. Alright, so this point that you have just given, the base point, that's like the axis. It's like the axis in the z direction. Now you are about to give it a pivot. So let's try giving it a reference point over here, and now as you can see, as you move your mouse after giving it a reference point, you can rotate your object like this. You can turn off the ortho. You can rotate your object like this. You can either rotate your object like this randomly and click and be done with it, which is asking you for a second reference point. So you want your object to be rotated from this particular reference point to this reference point. You can click and you can be done with it. Or in a different scenario, if you want a little bit accuracy, you can select your object and you can type in rotate and press enter. You can give it a center of rotation somewhere over here, and you can give it an angle, because in the first command you can see it's asking you for the angle or first reference point. In the previous example, we had given it a first reference point and then a second reference point. This time let's try giving it an angle. So you can give it an angle like 35 degrees and you can hit enter. So as you can see, it rotated itself to 35 degrees. So that is moving, scaling and rotating apart from using the gumball tool. So it totally depends on the kind of workflow you want to achieve. If you want a lot of accuracy in your modeling, you can use the command line for moving, scaling and rotating, and if you want fast modeling, conceptual modeling, you can use the gumball tool. Now let's take a look at some of the intermediate commands like join and explode. So I have my solid over here. Let's try using this one. So I have my geometry over here. So what happens if I explode this geometry? I can select my geometry and if I can type in explode. If I type in explode, which is this first command that you see, you can click on it or you can just type enter. When you hit enter, you can see it tells you exploded a polysurface into 6 surfaces. This cuboid was essentially a polysurface. It was made up of 6 faces. So you have exploded your geometry into 6 different faces now. So you can click on it and you can see and select these faces manually now. And individually they can be selected. So now since they can be selected individually, you can individually also edit them. So I can select my faces and I can move them like this, move them away from each other like this. I can perform the same action on this solid as well. I can select my polysurface and I can type in explode and I can hit enter. So now this particular surface has been exploded into 3 surfaces. So you have this particular face, you have this particular face which I can move up a little bit for a better understanding, and I have this particular face. Move this particular surface a little bit down. So you can explode your objects like this for a better view and better understanding. Now what if I want to join them back? So what if I use Ctrl Z and I bring my surfaces back where they were initially? Now if you look at this particular geometry, it has, if I select all of it, it tells me it has 6 surfaces added to selection. So this particular geometry is made up of 6 different surfaces. If I select them individually, they are selected individually. They are not a specific group or they are not joined by any means. So if I want to join them back, I can just select all of them, type in join and hit enter. Now if I select my object, it's turned back into a closed polysurface once again. So let's try using explode and join on this particular polysurface that we have for revising what we have just done. Let's type in explode and hit enter. Now this entire geometry, as you can see, has been exploded into different surfaces. I can join them back together by selecting all of them and typing in join and pressing enter. So now they are joined back again, as you can see. That was explode and join for any kind of geometry that you can create. Now let's take a look at the copy paste commands in Rhino 6. Let's copy paste this particular geometry. So you just need to select the geometry, need to copy, and so in this case, if I want to copy this particular geometry in the X direction, I will simply hold on to Alt and I'll move this geometry using the gumball tool in the X direction using this red arrow. Click on the red arrow and I drag it like this, and as I drag it, you can see a small white plus icon that has appeared near the red arrow tip, which indicates that you are copying the geometry. And once you're done, you can just leave your Alt button and the mouse button all together and you will have copied the geometry. You can try it once again. Let's try copying this particular geometry in the Y direction. So you can hold on to Alt and you can drag it like this and you can copy your geometry. So that was a basic copy paste move. You can also copy and paste your geometries using the command line, although it takes longer time. but you can do this. You can select your geometry and you can type in copy, and it'll ask you for the point to copy from. So if I want to copy this particular geometry from this edge, from this particular edge, so you click, and then it is asking you for the point to copy to. So if I want to place it on this particular edge, I can do it like this, and you can continue pasting this particular geometry as many times as you want, different places. For example, now if I want to place this over here like this, once you're done, you can just hit enter. So that is copy pasting using the command line and using the gumball tool.